HanselMinutes.com. It's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan, announcing show number 213, recorded live Thursday, April 29th, 2010. Support for Hansel Minutes is provided by Telerik RAD Controls, the most comprehensive suite of components for Windows Forms and ASP.NET web applications. Online at www.telerik.com. In this episode, Scott talks Aspect Oriented Programming with Philip Laureano.
Hi, this is Scott Hanselman, and this is another episode of Hansel Minutes, and I'm sitting down today with Philip Laureano. Philip is actually calling in from Hong Kong. Thanks for taking the time. I guess it's about midnight there.
Yeah, it's midnight.
Yeah, well, I appreciate you doing it.
Anytime, man.
So I wanted to talk to you because you focus on aspect-oriented programming. What is aspect-oriented programming, and why should I care?
Well, aspect-oriented programming is that missing piece of object-oriented programming that you've been hearing about over the past 10, 15 years. But it's kind of hard to explain if you think of it in traditional object-oriented design. I mean, with object-oriented design, you have these nice diagrams and stuff, but there's one dimension missing there, and that's time. There's nothing about object-oriented design that actually says, okay, we've got to have this one feature there only in certain times. And sometimes it shouldn't be there. For example, logging. I mean, everybody talks about logging with AOP, but one of the problems with traditional object-oriented design is the fact that if you put in a logger, you have to put in the logger in about 1,000 different places. And you could either have it in there or you could either not have it in there. And if you do have it in there, it's a maintenance problem because you've got to take all these different instances of that one logger that are scattered all over the place and somehow find a way to take that abstraction and make it nice and pretty, and you can't because it's either there or it isn't there. And when you so it's a big problem because I mean this is just a simple logger, but imagine there are other features in your application that you might need to have, like for example transactions, thread synchronization, things like that you won't be able to cleanly separate into different classes simply because they're just scattered all over the place. So with aspect-oriented programming, it's not, a lot of people say it's interception, but it isn't. What it really is a way of thinking about when things should be in place in your application and when they should not be. So for example, with the logger itself, you could say, if the application crashes, I want the logger to be turned on. But it's kind of hard to say that, at least with your traditional kind of notation or at least in code, without having to resort to some pretty interesting tricks that you normally rely on AOP to do.
Okay, so a logger is, like you said, the example that people always give, and it's a good one because of that notion of what they call cross-cutting concerns. A logger cuts through. And typically when you see object-oriented programming described in boxes and lines, it involves kind of a stack of things. It kind of looks like Tetris. And then when they describe AOP, they draw lines kind of perpendicularly, cross-cutting throughout those. What else is there other than logging that I might want to use AOP for?
Well, a really big one has to be lazy loading. For example, and Hibernate uses dynamic proxies, whether it's Castle or LinFu, to do this kind of lazy loading where even if you pull the object out of the database, it's not really going to make the query until you actually access the object's properties itself. I mean, it could be anything from like 5 or 10,000 records in one pass. But the point there is you want to make sure that you'll be able to use this. At the same time, you won't necessarily have to explicitly say, I need to use lazy loading, or I need to put that into my application other than through maybe a setting in Hibernate. The point of aspect-oriented programming is to have that kind of a nice separation of concerns without having to do some sort of really medieval cut and paste or copy and paste.
Did you just say medieval
that you would
cut
normally
and paste?
see in Yeah, I did.
I love that.
Basically, the problem is it's just there's no clean way to actually separate this out. It's either it's going to be there or it's not going to be there. I definitely don't recommend cut and paste, but from what I've seen in a lot of systems, what happens is you've got guys that have all these dependencies all over the place, and they have to use the dependency, so you can't really pull it out. Even if you were to refactor it, you can't. It's still going to be there. So the problem here is, I mean, you're back to the example with diagrams. I mean, in terms of object-oriented design, we're really looking at it as if, I mean, this is like the difference between a single frame and a series of frames in animation. I mean, that's a good analogy for it, because when we have an object model, I mean, you're looking at one picture. It never changes. But with AOP, it really goes to that idea that an object model can change at runtime, and there are certain features that can be introduced at runtime that may or may not be there when you actually compile the system.
Now, what did you tell me that was the first rule of AOP?
Oh yeah, I call it the Fight Club rule, because one of the hardest things to understand about AOP is the fact that it's supposed to be invisible. And if you have to explicitly use it in your application, then you're missing the point. Because if AOP is supposed to separate concerns, and then you're explicitly saying, I need to separate my concerns, then you're defeating the purpose. It has to be invisible.
So what do you use it for other than logging, though? I mean, like in like a production application?
Another one is thread synchronization.
Really?
For example, or caching. Yeah. I've seen instances where people tag a particular method or a property with a particular attribute that says something like single-threaded, so that what happens is once the method executes, it wraps it around a particular semaphore or a lock, and then you don't even have to worry about synchronizing it, because at runtime, the AOP part wraps it in a lock so that no matter how many threads try to hit that one property or method, it basically only goes through with one thread. And it's completely transparent, maybe aside from the attribute or maybe the actual code itself. I mean, you really don't see it. And that's probably why a lot of people shy away from it, because it looks like magic. And the truth is, it's not really magic at all. I mean, I've seen the implementations, and it's not as complicated as you think. The only reason why I would think that people think it's magic is you don't see what's going on behind the scenes, and it's quite simple, actually.
Would you say that this is one of those things that more people should be using? And it's like, I mean, like you said, it's the first rule is to not talk about it. Is this the greatest thing since sliced bread? I mean, should everyone be doing this, and just you have no idea why they're not doing it? Are you that into this?
Well, I mean, for me, this has been a passion for a long time, but I personally, it's no silver bullet, of course. It's just another tool in the toolbox. In my own experience, it's really made my object models really, really clean. I mean, we're talking like one class, one method in less than 20 lines long. It makes that kind of separation between the concerns and all the implementations that much more simple. I mean, then you tie it in with something like an IOC container, and then it's pretty much golden. Because of course IOCs handle all the construction, but AOP takes all these little bits and pieces that you put together with IOC and even separates it even further. So it's a great combination.
Okay, so how do you do this in .NET though? How is AOP implemented in .NET, and what do you have to do what's built in? Like, what does Microsoft ship, and where does Microsoft drop the ball and leave you to figure it out? Okay,
well, a couple of years ago, what happened with what comes with Microsoft is something called the context-bound object. And again, I call it medieval because it's just really, really crude, and it had these certain events that you could hook into. I think it was before or after a particular method call, and then you could add custom code to it. But where they really dropped the ball was it forced you to inherit from one base class. And sometimes you can't really do that with your model if you want a clean model that has nothing to do with, Microsoft's libraries other than maybe using some of the system libraries itself. That's Microsoft's implementation. There are other implementations like mine, which is LinFu for dynamic proxies. There's also Kessel. These are dynamic proxies, and basically what these things do is it takes any existing class and inherits from it at runtime, and then it takes all the calls that you make to that inherited class instance and redirects it to some sort of interceptor that allows you to inject your own custom code. There are other types of writers, IL rewriters, that people use for aspect-oriented programming. And one of them is LinFu, the other one is PostSharp, which is pretty popular. Basically what these things do is that they take your compiled assembly, disassemble it to some degree, and then reassemble it with their own custom code. So now it has all those nice aspects that you'd want to put into your application, like lazy loading or transactions or whatnot. And the last, and probably the one I probably will never ever do, is the unmanaged profiler API. Basically, you're working with the CLR's unmanaged C++ API for dealing with unmanaged code. You could pretty much hook into the JIT and actually change the instructions right before it actually compiles into native code. For me, I only stick with dynamic proxies and IL rewriters because most of the time they get most of the job done. If you're really masochistic, I would probably recommend the unmanaged profiler API.
So how does IL rewriting sounds really scary? I mean, it sounds like, just like initially, like my initial reaction is like, wow, really? I mean, I've just compiled this and now I'm going to go and mess around with it again.
Well, actually, that's one of the things about IL, misconceptions about IL that people are afraid of. Because if you look at the IL language itself, it's a really simple language. I mean, it still has all the same constructs that you would normally associate with, your CLR 1.0 language. For example, you got your if statements, which is a little different. For example, you got branches and there is no such thing as loops. But what the nice thing about using these libraries for IL rewriting is that you never actually have to do it yourself. And these libraries, whether it's LinFu, PostSharp, or Castle, or whatever, they're all well tested. So there's no way for whatever IL rewriter you're using to screw up. I mean, unless you do something really crazy with it. In most cases, the uses are pretty benign. I mean, I've seen a couple people put in pervasive method interception throughout their entire app, but I mean, even in cases where they want to intercept everything in the kitchen sink, I've never seen any case where it actually caused something to break simply because we had enough tests.
So what are some reasons why someone would be afraid of this, though? I mean, can you understand my initial aversion of like, I've just assembled this and I'm going to break it apart and then weave into it?
I think it's more psychological than anything. I mean, I think as programmers, we're pretty much control freaks. We like to have control of everything. And one of the things the trade-offs that you do have to have is that you have to surrender a part of your application and say, okay, yeah, I need to add a little bit more code to this, but when it actually changes the IL, it's going to be a little different. I mean, functionally, it's still going to work the same way. Like, it's still going to do the same thing for your business app. But when you look at Reflector, it looks completely different. How do
you debug that? I mean, if I'm going to go rewrite a bunch of IL, what happens when I decide to go and, F11 through my code?
It depends on the particular IL rewriter. If you go with dynamic proxies, you'll be able to step right through it, and you can just you'll see where it stops. In other cases where you have IL rewriters that do post-build time compiling, or where they modify the assembly right after a build, it really depends on whether or not it changes the PDB file and updates the program debug information, so that when you run through it, you'll be able to see what's going on there. So like I said, it really depends. But there's so many options that you could pretty much go with whatever you decide to, or whatever fits your need.
Which do you prefer?
Well, for me, I'm kind of biased. I mean, for simple scenarios, I'd probably use LinFu. For more complex scenarios where it's just really off the wall, I'd go with AOP, which would be LinFu.AOP. You could also go with PostSharp or
so just to make sure that for folks that are listening who may not speak English as their initial language, he's saying LinFu, LinFu, and that's a project that's up at Google Code. And then he's saying PostSharp, POST Sharp.
Actually, it's on GitHub now.
Oh, LinFu is not on Google Code anymore?
It's still there for historical references, but
but you moved it over to GitHub. I see there's a link right from there.
Yeah, there's a link straight away. LinFu is just one of those things where I just sat down and played around with IL, and then I realized that there's so many other language features you could probably implement with just writing the IL yourself.
Hey, it's Alternate Universe Scott Hanselman. Going to thank our sponsors for making this free show possible. We've been doing Hansel Minutes for almost 4 years now, and we really couldn't do it without Telerik. So I want to tell you about some of the stuff they're working on. If you've already started developing with Silverlight, then you probably need a solid testing tool to do your Silverlight UIs. Unfortunately, though, a lot of the tools available today only help you with unit testing. There's not really a good way to simulate the actual behavior of those end users, unless you spend days and weeks doing a lot of manual testing. But the guys at Telerik have got a new point-and-click UI testing tool for Silverlight called Web UI Test Studio. And the beauty is that you can quickly record your tests with a cross-browser recorder. You can enrich them with code if you've got really complex scenarios. And on top of that, it supports all the standard controls as well as the Telerik enhanced controls. You can verify not only Silverlight, but even complex Ajax applications. Best part, Web UI Test Studio lives in Visual Studio, so you don't have to leave your favorite development environment. You can check it out at telerik.com/web-testing-tools. And be sure to thank Telerik for supporting the show on their Facebook fan page at facebook.com/Telerik.
Okay, before we start digging into how someone can get started with LinFu, talk a little bit about dynamic proxies. What is a dynamic proxy and how does that work?
Dynamic proxy is basically special. When you look at it, it's if I were to write it manually, and you were just to write it in, say, C# or VB, what you're really doing is you're inheriting from a class that has a bunch of virtual methods. And for every single one of those virtual methods, you redirect it to some interceptor instance that has all the information, like the type arguments, the method arguments, the method name. And based on that input, you could actually change or make it act like a real object. It's a dynamic implementation of the proxy pattern. I think it was around 2004 or 2003, somebody figured out that you could take reflection.emit and you can take any given type, provided that its properties were virtual, and then redirect those calls back to something that looked exactly like the object. It was pretty brilliant. I can't claim that I invented it because I didn't. But that's basically how proxies work. On the Java side, I believe they have it built in, but for the .NET side, we basically had to create our own.
So dynamic proxies that's something I can get within LinFu. So that you're saying that there are multiple flavors of AOP. There's dynamic proxies. There's IL rewriting, actually digging into the compiled stuff that you just made and emitting more IL. And the LinFu framework has all those different things available, so I can use different tools. It's a whole toolbox of stuff.
Yeah, and the best part is you don't even have to see the IL. You never see it. It might sound scary because I'm saying that, you have to...
You're giving up control.
Yeah, you do have to give up control. But, it's pretty... for me, I think it's a worthy sacrifice compared to seeing all this stuff look like, at least on an architectural level, like it's copy and pasted everywhere. Things tend out... I hate to generalize, but for me at least, it comes out much, much cleaner when you don't have to see like 6 dependencies in 100 different places. Instead, you probably just see it in one place. And with aspect-oriented programming, you get to say where these particular dependencies should be at runtime. And that's the difference. With traditional object-oriented design, you just say it's either there or it isn't there. You can't really say when it should be there or when it shouldn't be there. And that one extra dimension makes a huge difference in making sure that everything's clean.
Okay, so I want to get started with LinFu. I've got my, maybe I'll take Nerd Dinner, right? I've got an existing ASP.NET application, and I want to add, let's just start with logging. What do I have to do to get started with LinFu?
Well, with LinFu, depending on what you want to do with your ASP.NET application, if it's MVC, you probably want to hook it in to as one of a controller factory. And it's like one of the very few controller factories that could pretty much take an infinite number of arguments, and you could pretty much parse it out like that. So the first thing that you would do is you'd hook it into your controller factory. After that, there's a gazillion different ways that you could tell the IOC container itself, okay, once you create this, I want you to hook into this particular aspect, or introduce this particular feature. Like, for example, I've got a friend in Norway, and he was able to introduce WCF to an object model that was just a plain old CLR object, and you don't even see the WCF at all. It's just like one line. And all he did was he just put in a hook into the container and says, okay, once you create something and once it comes out of there, I want WCF support.
Mm-hmm.
And it was pretty amazing considering it was just like magic. It was 1 minute it's there and the next minute it wasn't there. But when you look at the object model, it's just a bunch of properties.
Someone had complained to me recently at a presentation about some of the complexities of WPF around event notification and how basic properties when used in WPF have to get really complicated, especially with the notifications and stuff. Are there examples of using LinFu to clean up WPF objects that are used within the context of WPF or Silverlight?
Oh no, there aren't any examples with LinFu and WPF, but there are a couple examples with Bernhard Richter. I'll post his blog, and what he did was he actually put up he's got a project up called I can't remember the project, but we'll post it later. But he has a project that actually puts an iNotify property change implementation as well as iData error validation, and it's pretty much transparent. For example, you could have this one particular interface that validates this one particular class type, and you just drop the DLL into some directory, and LinFu scans it and then injects it right into the container. And the container's smart enough to say, okay, this particular instance needs to be intercepted, and I need to put these features onto that one particular class or object. It's pretty smart, and a lot of containers can do that. But at least for LinFu, it's one of the interesting contradictions. It does a lot of complicated things, but for most of the time, you get most of the job done in about 1 or 2 lines of code and no fuss. I mean, you never really see any IL at all unless you really want to get into it.
Gosh. What if I have to debug these things? What if I've changed something? You keep saying that it, I guess we both agree that it can be scary, but it's psychological. And then you're saying that I don't necessarily have to see the IL, but what if something goes wrong? How do I debug my logging if I can't even see where it got called?
Well, you still get to actually see the logging, because once the IL calls back to your code, it tells you where it's actually being called from. In layman's terms, it's like it's dialing home. It's pretty much telling you where it was intercepted. It gives you all the information you need to say, okay, this was intercepted here, this was intercepted here, as well as you do give up some control, but the control that it gives you back is you get to decide where and when these particular points of interception execute. For example, in dynamic proxies, you will often get the method info, and it'll tell you everything you need to know about the particular method that is executing. And it has everything there, including the arguments, whether it's a generic or not. So basically, on one hand, you lose control about how it's actually compiled, but when it actually runs, you get to decide where things execute, how they should be executed, and whether or not you should just replace the code altogether. I mean, it sounds scary, but it's actually quite simple.
Okay.
and a lot of it is abstracted away for you.
So I put this into Nerd Dinner then, and I plug it in, like you said, to a controller factory. And then what are some of the different kinds of interception I can do? I mean, I can intercept at the class level. So I could say, like, I want all dinners to be intercepted. And then could I intercept more granularly than that?
Oh, absolutely. You could intercept at an instance level. So if you have one particular instance of that one class, you could just go ahead and intercept pretty much anything on that particular class instance. The types of interception we go over, at least for LinFu, is there's method body interception. That's basically you can take any method body, whether it's sealed, static, private, or public, and you could pretty much swap out the method body implementation. There are a few restrictions. For example, you still have to return the same type, but for the most part, you can pretty much do whatever you want with it. The other one is method call site interception, which would scare a lot of people. Basically, I could take any system or any third-party method call and replace it with your own. For example, if you had a Hello World program and you wanted to replace it so that it would instead send the Hello World over a network socket, you could easily do that and you just swap it out. The other one is new operators interception, which is the ability to take your standard C# new operator, or in IL it would be the new obj instruction, and you basically wrap an if state in IL. What it's actually doing is it's wrapping an if statement around it and saying, okay, should I just let this thing create itself, or should I provide something else in its place? And it's pretty handy in some certain situations once you want to trace object construction. The other one is field getter and setter interception. So, for example, I could take any field and intercept the point where it's actually being accessed or changed. So if I were to set a foo field, I could actually prevent it from being set, or I could actually just replace it with another value with whatever I want. The last type is what I call thrown exception catching, which is the ability to dynamically catch any exception thrown from any given method. There is a small note at least with LinFu's way of doing it, which is it's kind of opt-in. So you have to explicitly say, I want to catch exceptions out of this method, and if I do catch it, I either want to swallow it or I should just let it rethrow itself back out. Those are the kinds of interception that LinFu provides. Of course, your mileage may vary, and I really leave it up to the responsible developer to actually figure out what they want to do with it. But it gives you a lot of flexibility. At the same time, you never ever see any line of IL.
Do you find yourself doing static IL rewriting? Static IL rewriting makes more sense to me. The idea that I'm going to take some code and I'm going to compile it into IL, into DLLs. And I think sometimes some newer .NET developers forget that there is IL. I mean, they think that they compile and then this binary pops out, but there's IL in there. And it makes sense, like post-build steps I can deal with, like emotionally, I get that. But dynamic IL rewriting, that seems scary. Like I'm over the, hey, I'll rewrite my IL part of things, but I'm not over the, I'll do it dynamically.
Well, it's actually two steps. When you're dealing with static IL rewriting, it's basically that post-build step that changes your assembly. For example, I know PostSharp, as last time I checked, they do static IL rewriting, so you could mark a particular attribute on a particular method, and all of a sudden it would just change that one particular method. With LinFu, it goes dynamic by taking that same static step, but instead of putting in a specific type of aspect or piece of code, it wraps a small little framework around your method. So what happens is it'll ask you, once that framework is in place and you run the program, it'll ask you, okay, I'm inside this method. Should I intercept it or should I not? If you don't want to intercept it, it acts like it's not even there. So when we're talking about dynamic IL rewriting, what it's actually, it's static plus runtime interception. That's a more accurate term for it. The benefit, of course, for dynamic IL rewriting is you can pretty much decide where you want it to be. There's also, in terms of build time, it's pretty much negligible. It's not like static, where you'd have to basically filter through everything and decide what you want to put in and what you don't, because there's some decisions about what you need in the application that cannot be decided at compile time.
Okay, and there's where it gets interesting, and that's where I think of things like authorization.
Yeah, I mean, there's no way you could actually put in authorization at compile time. It just sounds silly. But at runtime, it makes perfect sense, because you need to be able to get this information when the program's running. And of course, you're not going to be able to get that if you have something statically compiled and you don't know what machine is going to run on and all these different settings that you might be worried about.
So what do you think the future is for this? I mean, is this going to be? How many people? Let me ask the hard question. I was going to try to be nice, but let me just ask this: who's using this other than Philip?
Well, right now this is the tool of framework geeks. I mean, it sounds scary, but I honestly think this is, at least on the .NET side, it's one of those rare things that you won't hear about. I mean, on the Java side, they've been using this a lot on Aspect-J, and they take advantage of this a lot. And this is, again, you did bring up a valid point that this is pretty exotic. I mean, I don't recommend it for everybody, but it's definitely another tool that you put into your toolbox. As far as people that use it, I mean, pretty much anybody who uses in Hibernate uses some form of dynamic proxy. Mm-hmm. It's unavoidable. It's either Castle or LinFu. I mean, and even in your practice, I mean, you probably used in Hibernate more than a few dozen times. But the thing that's nice is you never really know that there's a proxy there. They never really, I mean, aside from maybe that setting that they say, okay, pick one proxy. But for the most part, they never really, you don't even realize it's there. And that's the beauty of AOP. I mean, they're doing all this stuff for you, but it's all in the background. So the future, at least for AOP, is that it's going to be invisible, but there's still a lot more interesting things that I would love to dive into. I mean, maybe I could talk about more on multi-threading, or use AOP to do transparent IOC container injection. For example, one of the big things that they're trying to do with some of the containers right now, even with MEF, the Managed Extensibility Framework, is the big question there is, how do you make it invisible? How do you actually make extensibility invisible while at the same time allowing users to be able to take advantage of it? With AOP, it allows you to add those features into place without necessarily telling the end user dev that you got to put this in yourself.
I think that nails it. I mean, that's the way to do it. There are things that developers shouldn't have to worry about.
Exactly.
When you think about separation of concerns, this allows you to do separation of concerns organizationally.
Basically. And the other thing is, I mean, there's so many things that a developer has to worry about nowadays that, I mean, if you're talking about like the second or third tier framework guys, like the architects, these guys, I mean, for me, it's my job just to make sure that when it gets down to the grunt level or your average dev, they don't see this. I mean, they don't have to worry about lazy loading. All they got to worry about is the business domain. And at the end of the day, that's really the focus here. We want to take away all the plumbing so that once you strip everything away, the only thing that you see is the business domain. And I think that's what's missing right now, because once you look at these different frameworks, they have everything from security to logging to transaction management, and it gets confusing once you go through the code. AOP offers that kind of separation, of course, but it's going to take some time before people wrap their heads around it. I mean, it took a while for people to switch from imperative program to event-driven programming, and I think that's the shift that we'll see within 5 or 10 years. In the same way everybody takes object-oriented programming for granted nowadays, I mean, that's, I think, where we're going to be within 5 or 10 years with AOP.
In closing, give me something that people can take action on. So someone's listening to this, they're sitting in the driveway of their house or their place of business, and they're like, all right, I'm going to go download LinFu. What's an exercise that they can do with an existing application that'll light them up?
Well, one of the things that you can do with LinFu and even AOP is Xcopy deployment. I mean, we're talking about instant pluggability. I mean, Meth has been talking about this for a while, but I was doing this back in 2007. Basically, the idea is with AOP, you could just plug things right in without even changing a line of code. Like, for example, there was one project where a guy took LinFu and it took his 5-year-old web app and they couldn't change the production code. So what he did was he actually plugged LinFu into it and he was able to change it without changing a single line of code. Everything worked, all the tests passed. It just works.
So I could change an app I don't even have the source for?
Correct.
That'd be interesting to add logging to an existing app, but you're either afraid or unable to recompile it.
Oh yeah, and it happens a lot. There are other things I've played around with. Is you could actually add wrap unit tests or observe existing code so you can see what the input and the output of each method is. So I could actually write, your Michael Feathers working effectively with legacy code type tests where you put in, legacy characterization tests, and you don't even have to touch the code. You just have to observe what comes in and what comes out, and then you write the assertions. But that kind of thing it's only possible with AOP because you don't want to mess with production code, especially if it works.
Yeah, definitely.
If you've got unit tests, even better, because even if you plug the AOP right in, you'll still be able to verify that it works. And in 99.9999% of the time, it works. And you could easily verify it with the tests if it doesn't.
Very cool. Well, Philip Laureano, thank you very much for taking the time to call in. And I know you're up at 1 a.m. in
not a problem,
in Hong Kong. And I'm going to put links up on the show notes for your blog, for you on Twitter, your twitter.com/Philip Laureano, and also LinFu, which is now hosted at GitHub.
Correct.
Thanks so much for the time.
Thank you.
This has been another episode of Hansel Minutes, and I'll see you again next week.